let's see. Okay, so right here, yeah. So autonomous drone control with computer vision. So basically our project was that we took these two consumer drones and we essentially wrote the software that allowed them to fly themselves. So I'm going to recreate this project. The key components to this project are the Microsoft Xbox 360 Kinect, which we have in the corner. And inside of this box is, let's see, is the remote to the drones. And then right under it is actually a breadboard connected to Raspberry Pi. Let me see if I can't lift that up. Show you. Oh yeah, some more of the remote innards. And then right under there peeping out is the Raspberry Pi 3B. Cool. So I'm going to show you some of the cooler things about this project. And then by the end of this video, I should be able to demonstrate it flying right in front of this cloth. I've actually cleared out my post-college room right here so that we could demonstrate this project. So let's get right into it. Okay, so I have my capstone presentation from the day of, and I just want to go over it really quickly because there's like some structural things that we can get. Thank goodness I already had these diagrams. So yeah, let's see. So set this right up here. So we talked about some of the challenges with these systems. You feel free to pause as a viewer of this presentation to like see the details that are in it. But like the overall thing was that we were going to move some of the hardware from the drone to like a local computer. So like this machine plus that Kinect in the corner that we were talking about. That Kinect with this machine can do a lot of the work that we were going to be doing on the drone that has historically been done on the drone. So this is the stack, and it sort of breaks it apart into like what parts, what kind of sciences you needed to do this. So the Kinect, I don't know if you ever used one, but they allow you to play games where you like move your body around and it sees like sort of how far away you are from stuff. The main thing is that it had really good depth. And the way that this works is it has an infrared camera. Well, it has a regular camera, so we can like see what things look like, and you can see yourself when you're using it. But it has an infrared camera and this infrared dot projector. So the output from that camera, it actually looks like this. So it's just a field of dots. Let me turn off this light. It's a field of dots. And you can see someone walking into this field of dots, and you can see the dots sort of stay in the same place, kind of, but they move a little bit when something in that field of view moves. So let me show you what's coming through the RGB camera now in that same room at the same time. So you can see it was like sort of dark, and the only thing that was there was the light from the infrared dot projector. So that allows it to do the same depth using disparity in where those pixels are based on where it thinks it should be at whatever depth level. To sort of create a depth for that environment. So this is the color image. We just looked at the dot projection thing, and now we can actually see the depth map that Microsoft Systems is able to create for us. Let me see if I can't make that a little bit darker. There you go. So it's the same room, and like we just knowing how rooms work can see that the chair is closer to everything. And then the floor, as you get closer with the floor, that becomes greener. So the greenest things are the closest to us. It actually becomes quite red when things get even closer. Okay, so what we can see is that it creates this great depth map for us. So all that math that we were going to do with our stereoscopic camera system here, it gets done by the Kinect automatically for us, and we get this data out. So while they've created this wonderful way to display this data, that's not how we process it. We view it as like a value from like 0 to 1,000, and we treat that as how far away something is in the room. What's important about the depth map is that we use that to understand where the drone is in 3D space. The most clever thing that you'll see is that this green puff on top of the drone is how we track the drone. And you can see right here, it's sort of floating above nothing. So that gives us depth information. And we take it with the RGB image of the room to figure out where it is in like X, Y. And that is basically how we track the drone in 3D space. So that's one part. This is our raw data. So yeah, the presentation goes into what we're saying. Again, sensor fusion, we bring this information together of the RGB image and the depth data to create enough information for us to be able to like know where this drone is. So yeah, but that's what our program interface looked like as well. So you could see the drone, you could assign a color that it would be looking for. So in this case, we were always looking for the green of this puff that was on top of the drone. And we were able to sort of track that using this, and you can see like weighted averages. We'll get into this later. Weighted averages, the instantaneous position where we think it is. And then you were able to set like the depth using the slider, and you'd be able to click the X and Y on this screen. Cool. Thanks for checking out this video. Check out the other videos in this series. And if you've liked this, you can like it. And if you want to subscribe, you can subscribe. Peace.